Image-based geolocation is a difficult problem in terms of accuracy, data collection, and runtime. Built by Mosaic, Divined is a state-of-the-art geographic indexer and geolocation engine that wields the power of deep learning for image-to-coordinate search. Divine stands for Deep Image Vector Imputation for nearest element discovery. In this process, both the queried side image and each location on Earth's surface are encoded into a higher dimensional vector representation. For terrestrial indexing, Divine can index and encode over 150 images per second and is scalable to large geographic areas. On the home dashboard, users can view any current indexing jobs either underway or in the queue. On the Training Datasets page, users can see datasets that were created in previous indexing jobs. Each of these includes multiple types of imagery, such as Google Street View, overhead, elevation, and OpenStreetMap. Users can also see the indexing status for each dataset. To generate a new terrestrial dataset, users can start a new indexing job to gather the required imagery. They have the option to either import a previous region or define a new one from the GUI. We now define a rectangular grid on the map. We can either include or exclude points over water, select a spatial grid resolution, and select the number of orientations for each image. We can also use population density to either increase or decrease the grid resolution over metropolitan areas with a high amount of urban infrastructure. We see this example will cover approximately 20,000 square kilometers with 765 points. Finally, we set the types of imagery that will be included in the new dataset. After defining the bounding box and image types, we can execute the indexing job, which is launched on parallel AWS Lambda functions. By default, the indexing job is launched on 1,000 threads concurrently. Here we have all the possible transformations for the datasets used in indexing and querying. The index vector generation transformation is distributed across multiple GPU-accelerated EC2 instances and uses a trained model to transform the images into a searchable vector space. Users have the option to select both which model architecture will be used to perform the transformation, along with which specific version of model weights. Due to the modular architecture of Divined, users can swap in updated models for continuous improvement. To submit a new query, the user can upload either a single or multiple images to search on. They also set the number of nearest neighbors to return from the query service. Each of these query images are vectorized with the same Divine models used to transform the index dataset. Querying is performed by FACE. The Facebook AI Similarity Search, also known as FACE, is an ultra-fast GPU-accelerated nearest neighbor search capable of searching over billions of entries in a timely manner. In this example near Taiwan, 51 images were requested for geolocation to return the 500 closest matches. On the map, we see the results of the Divine query, with the most likely returns ranked for each image. Compared to other geolocation engines, such as the NGA, a Divine query takes seconds compared to hours. This has specific application in intelligence, disaster relief, and law enforcement sectors where response time is critical. By using the most modern models and searching over a latent space, Divine demonstrates a functional environment for both accurate and lightning-fast image-based geolocation. Interested? Contact Mosaic ATM to learn more.